We've taken a look at a couple of these homemade PDFs in Desmos so far. I'm going to show you two ways of doing the same thing. One of them is going to be a review, and the other one is going to be something that we haven't really looked at yet. I have this random variable x that can take on legal values between 0 and 5 pi over 2. And we know that for whatever reason, a variation of the function x equals cosine x is going to be our go-to PDF. That's going to be how we start thinking about our density function. You know, the density function has to follow two rules. What are they? Well, first of all, over our legal values that our random variable can take, in our case 0 to 5 pi over 2, the PDF can never go negative. And secondly, the total area under the curve for our specified legal values of our random variable, 0 to 5 pi over 2, that total area under the curve has to be 1. Let's take a look at the way that we've shown you before, and let's also look at a new way of doing this. We see 0, 0 at pi over 2, the function or the PDF takes on a value of 0, and then it goes down and it hits its low at 3.426, negative 3.288, and then it swings higher again, and it really never goes negative again for the legal values of interest to us. We don't have to worry about values that are not relevant or pertinent. So this function goes on forever in both directions, but we only have to worry about the values that x can legally or sensibly take. For us, 0 to 5 pi over 2, right? So let's fix the first problem in the way that we've done it before. When x equals 3.426, y hits its min value of negative 3.288. So as long as we add something at least negative 3.288, then we're going to be fine. So I'm just going to add 4. That still does the trick, right? So now we're only thinking about these values here, and just to kind of blind out everything else, I'm going to say the x-axis can take on values from 0 to 5 pi over 2. That's it. Okay, so this is the range that we're looking at. Probably you're thinking about, okay, well, hey, the area under the curve has to equal 1, so how do I do that? And so I'm going to just put in int, so into integer, and from 0 up to 5 pi over 2, and then I'm going to put parentheses and a dx outside, and I'm just going to type it in, x cosine x plus 4, and I get that the total area under the curve is 38.2699 units squared. How am I going to modify my PDF? Well, what I can do is I can just go right up here if I like and divide everything by this value. So just copy and paste, and to show what we did, our value is maybe not quite 1, but it's really, really close to 1. If we had more precision in Desmos, then we would get there. We now have a legal PDF, and I can find the relationship between the density, which is this is the PDF, the probability density function, and the probability, which is the area under the curve. It's a quick reminder. If I wanted to do that, remember I'm defined from 0 up to 5 pi over 2. I'm going to change these. We're going to make our y value between 0 and 1. In fact, we really don't even need 0 and 1 because this thing hits a maximum density of quite a bit less than that. So let's go in again and make this 0.4. Cool. So that's what we're looking at. And just to see, I'm going to put all of this, I'm going to copy paste into here, and I'm going to put a dx out front. And I get this 0.99999. As long as I change up my minimum and or my maximum value, and they're within these boundaries, then I can see what the corresponding probability is. So like if I said, well, you know, what about just 0 to 1? What's the probability that my continuous random variable takes on a value between 0 and 1? Well, there's a 11.449% chance that that is what's going to happen. I don't have to only change the upper bound. I can change the lower bound. So I can say, well, what's the probability that it takes on a value between 0.5 and 1? Well, there's a 5.9% chance. Or if I want to keep the upper bound set, 5 pi over 2. Well, there's a 94.4% chance that my continuous random variable takes on a value between 1/2 and 5 pi over 2. Great. So that's one way that I can accomplish this. Hopefully this looks fairly familiar to you. Here's another way that we can modify this. This is going back to our original y equals x cos x. Remember, there's this area in the middle where x takes values between pi over 2 to 3 pi over 2, and in that region, the function y takes on negative values, which of course is a huge no-no for a PDF. So what we did last time is we just added 4 to the whole function, right? And by adding 4, we got around the problem. But the other thing we can do is just say that our random variable x cannot take values between pi over 2 and 3 pi over 2. Now, what that means is that we don't have to worry about negativity at all. Our function is positive over this region, and it's also positive over this region here. The only thing that we have to do is ensure that the area under both curves is equal to 1. And so the way we would do that is we would say int 0 to pi over 2, and then we would copy paste, just go x cos x dx, and then we would add int 3 pi over 2, 5 pi over 2, x cos x dx. And by adding both of these, what we find is that the total value is 13.1371. And if we just go out front, probably you're familiar by now, and you divide it by 1 over 13.1371. It's very, very close, right? And now all of a sudden we are dealing once again with a legal probability density function, a PDF. But the main difference is instead of just adding 4 to the whole function, now I've sliced off and said that there are 2 legal ranges that my PDF can take, and that is perfectly acceptable.